Hey guys, and welcome to our new unit, which is going to be systems. And today we are looking at systems of equations, which is going to mean two or more linear equations. And of course, we remember that linear means only one x, okay? So now in our algebra class, we're just going to focus on two linear equations, but it is possible to have more linear equations, okay? So the solutions to a system we can find graphically, and it's going to be the point xy where the two lines intersect, or where they cross. And algebraically, it's going to be the point xy that makes both equations true. Alrighty. Today we're going to focus on graphing. So there are three types of solutions when we are graphing. The first one is intersecting lines. So if I have, let me draw my little graph here. This is y and this is x. Now, if I have one line going something like this, and then my second line, because remember two or more equations, and I have my second line going something like that, then this is the point of intersection, and this point here will be our solution. Okay? And because we did not actually graph it to scale or include numbers or anything, that's why we're saying this point is xy, but normally it would be a number. Alrighty, then for parallel lines, this is another solution. So if I have parallel lines, parallel means that they continue forever in one direction or in two directions, but they never touch because they go left to right and they will never touch. Doesn't matter how far along the line you go, they will never touch. All right, and then finally, we are going to have the same line. And yes, I do realize that I skipped the type of solution, but I'm going to talk about that again in a second. So when we have the same line, this means that we have a line that goes something like, oh, I don't know, something like that. And then we have a second line that also goes something like that. And it's going to be the same line. So let's go back to our intersecting lines. So when we have a point of intersection, that means that we only have the one solution, and that's our xy point. Now, when we have our parallel lines, because they never cross or intersect, we have no solution. So when that happens, you can write DNE, which means does not exist. Alrighty. And then when we have the same line, that type of solution is infinite solutions. And that's how you draw infinity. And this is because every solution works. Because the lines intersect here, 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 and every single point on the line is where they intersect. Alrighty, so now that we have gone through our types of solutions, we're going to learn how to solve our systems by graphing through three steps. So our first step is to make sure our equations are in y equals mx plus b, which is, of course, our standard form for linear equations. And then our second step is going to be graph our lines, which we have done many times. And I like to use different colors, so I'm going to say different colors help. That way you can see both of your lines. And it'll come really in handy later. And then finally, we need to find their intersection. Cool. Alrighty. So that's how we are going to solve our systems of equations. Alright, so now let's go down to our first example. So we have two lines. We have y equals x minus 8, and we have y equals negative 2x plus 1. So as always, start with your first line, and we are going to graph negative 8. Remember, this is our y-intercept. So we're going to go down 8. 1, 2, 3, 4, 5, 6, 7, 8. And then from this point, we are going to graph our slope. And remember, when we have just x, that means our slope is 1. And because our slope is a whole number, you have to put it over 1. So it's going to be a rise over a run. So up 1 to the right 1, up 1 to the right 1, and so on and so forth. And then when you run out of graph, do the opposite, because we did up 1 to the right 1. Now we're going to do down 1, down 1 to the left 1, down 1 to the left 1. So ignore that little blurb that I made right there. That was Miss Johnson having a brain fart. There we go. And we have graphed our first line. And if it helps, you can put a little dot of the color that you used next to that line. That way you remember which one it is. And now we're going to graph the negative 2x plus 1. Okay, and I'll go ahead and make my little dot. So graph your y-intercept, which is 1, because that's our b. And this time our slope is negative 2. So because it is a whole number, we need to put a 1 underneath it. And remember, it's rise over run. Negative means down. So down 2 to the right 1. Down 2 to the right 1. And so on and so forth. And then when you run out of space, do the opposite. Now we're going to go up 2 to the left 1. And then connect your dots. And our solution is going to be the point of intersection. And our point of intersection is this point right here, because it's where the two lines cross each other. So then we just need to find what point this is. And remember, when we write points, it's in the form x, y. Okay? Solution x, y. So I'm going to count 1, 2, 3. So this is 3. And then negative 1, negative 2, negative 3, negative 4, negative 5. So our solution is 3, negative 5. Doing okay? Alrighty, let's try the next one. Alright, so now we have y equals 1/2 x plus 9 and y equals negative x plus 6. So do the same thing, start with one color. Always graph your y-intercept first, which is going to be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, y-intercept always goes on the y-line. And then from there, we take a look at our slope, our rise over our run. So I'm going to go up 1 to the right 2. And then I run out of space. So now I'm going to do the opposite. Down 1 to the left 2. Down 1 to the left 2. And so on and so forth. And then we connect our dots. Now we graph our second line, y equals negative x plus 6. Start by graphing your y-intercept, which is 6. 1, 2, 3, 4, 5, 6. And our slope is negative x. So remember, when there's a negative in front of our x, it's actually a negative 1. And because it's a whole number, that means that we have to put a 1 underneath it. So this is negative 1 over 1. So we are going to go down 1 to the right 1. Down 1 to the right 1. And then when we run out of space, we go the opposite. So up 1 to the left 1. And then we connect our dots. And now we want to find our point of intersection, which is this one. So now we must count. Remember, this is your origin. This is where we always start from. So negative 1, negative 2. So then our x is negative 2. And then you want to count up. 1, 2, 3, 4, 5, 6, 7, 8. And so that is our solution. Y'all are doing good, guys. Alright, if you need a minute to practice, go ahead and, if you need a minute to review what we just did, go ahead, restart this video, maybe get some graphing paper and try to do this on your own. Okay? And then I'll see you guys in a second. Alrighty, so now we have some practice problems. So let's practice by solving by graphing, and don't forget to verify. Alrighty, so then I think you guys should practice the first one and second one, just graph it. Okay, so this is going to be you, this is going to be you, and I'm going to show you number 3. Okay, so take a minute, pause the video, and practice these. Alright, so hopefully you have practiced those and have gotten them checked by me. And now we're going to move on to this problem. So we have y equals 1/3 x plus 2, and we have x plus y equals negative 2. So let's start with the easy one. We are going to go ahead and graph 1/3 x plus 2. So start by graphing your y-intercept, which is 2. So 1, 2. And then graph your slope, which is 1/3. So rise 1, run 3. So up 1 to the right 3. Up 1 to the right 3. And then when you run out of space, do the opposite. So down 1 to the left 3. Down 1 to the left 3. Down 1 to the left 3. And connect your dots. Alrighty, our next question, or our next equation, is a little bit tricky because this is x plus y equals negative 2. If you remember on our previous page, we said to make sure that our equation was in the form y equals mx plus b. And this is not in our proper form. So we have to change this around a little bit, and we need to solve for y. Okay, so off to the side, I'm going to do it over here. I'm going to rewrite x plus y equals -2. Okay, in order to solve for y, we need to get y by itself. So to do that, I am going to subtract x from both sides. Because remember, we got to be on the opposite side of our equation. X minus x gives us 0, and we are left with y. Bring down your equal sign, and then -2 minus x. Okay, -2 minus x. But this still isn't in our proper form, so we just need to switch around some of our letters. So we're going to keep y as it is, because remember, we like our x to be first. So y equals -x minus 2. Alrighty, so this is what we're going to graph. Start with your y-intercept, which is -2, and then your slope, which is -x. So your slope is -1, which means that it's going to be -1 over 1. So down 1 to the right 1. And then up 1 to left 1. And then you connect your dots. And then find your point of intersection. Alrighty, so count, starting from the origin, -1, -2, -3. So your x is -3, and your y is +1. So down here for our solution, we have x equals -3, y equals 1. Alright, so where it says verify algebraically, and now you will be able to do this part for your other problems as well. We are going to substitute in the x and the y into each equation. So for our first equation, which I used for green, and I'll use pink. Okay, we have y equals 1/3 x plus 2. Okay, so y we said was 1. So I'm going to have 1 equals, whoops, sorry, forgot my colors. 1 equals, we have 1/3 x plus 2. And our x was -3. Okay? So first thing we need to do is simplify. So we can go ahead and multiply. So I'm going to have 1, because you bring down the 1, equals, now what is 1/3 times -3? Well, this is going to be -1. And then bring down the 2. And then we still have 1 equals, and we need to simplify. What is -1 plus 2? Well, that's going to be 1. So 1 equals 1. This is our true statement, because 1 does equal 1. Alrighty. If we had gotten 1 equals 3, then that's not true because 1 does not equal 3. Okay? So we know it worked for our first equation. Now we have to check for our second equation. So for this one, sorry, I forgot to mark that was red. We have x plus y equals -2. So I have my x is -3 plus my y, which was 1, equals -2. -3 plus 1 equals -2, and then bring down your equal sign and your -2. So that one was a lot easier. So this one is also a true statement. You might be saying, but Miss Johnson, this one was 1 equals 1 and this one is -2 equals -2. That does not matter. What matters is that when you substitute in the numbers, it comes out with a true statement. Okay? These numbers have to be the same and these numbers have to be the same, but these numbers do not have to be the same. Okay? Alrighty. So now I want you to pause the video and try to verify algebraically your two previous solutions. Alrighty. So now you have verified your solutions. We're going to go over here. Alrighty. So now we have y equals -1 and x equals 2. So y equals -1 is where y will always equal -1. So where y always equals -1 is this line right here. Because you go down to -1 to y equals -1, and then you can tint every single dot is where y equals -1. Okay, and we've talked about that before. And then you're going to do the same thing for x equals 2. Go to where x equals 2. And you're going to make the line where x always equals 2. Alrighty? And then your point of intersection is right here. And you won't believe what the answer is going to be. Are you ready for this? Your x solution is 1, 2, and your y solution is -1. So this is at the point 2, -1. Look at that. Cool, huh? Alrighty. Let's try the next one. Y equals x plus 1. And y equals x minus 4. So, start by graphing your y-intercept, and then graph your slope, which is going to be 1 over 1, because hopefully you guys are pretty good at determining slope by now. Cool. And then y equals x minus 4. So go down to your y-intercept of -4, and your slope is going to be 1 over 1. Wow. After we connect our dots, look at this. These are parallel lines, so there is no solution. This is a does not exist because they're parallel lines. And you can actually tell that from your equation. The way that you tell if it's parallel lines is if it has the same slope and different y-intercepts. when it has the same slope and different y-intercept, then you are going to have parallel lines. Now, when you have the same slope and same y-intercept, that's going to be the same line, and that's when you have your infinite solutions. Alrighty. And now we can look at our very last one. Okay, y equals negative 1/3 x, and x equals negative 3. So this time, our y-intercept is 0, because remember, if there's not a number, it's 0. And our slope is negative 1/3 x, so down 1 to the right 3. And then up 1 to the left 3. And as always, connect our dots. And then x equals negative 3. So go to where x equals negative 3. 1, 2, 3. And draw the line where x will always equal negative 3. And there's our point of intersection, right here. So surprisingly, she said very sarcastically, our x is going to be negative 3, and then our y is going to be 1. Very good, guys. You have just completed solving systems by graphing, and honestly, this is going to be the easiest topic in our systems of equations, so please make sure that you do lots of practice of this so that you understand it, okay? All right, guys, good job.